This is the lesson 3.3 teaching point and mini lesson. Today you will know how to set up and solve percent proportions, which that was actually from yesterday, but you're going to be able to continue to do that. And we're adding percent equations and how to convert between decimals, fractions, and percents. You will be skilled at solving problems using percent equations or percent proportions. So this lesson, I actually took the exact same questions that we had in yesterday's mini lesson, but I'm going to show you a different method to use to solve them. So this time we're going to be using something called percent equation instead of the proportion. So I marked my text the exact same way as I did yesterday. So you'll see this is the exact same prompt, and I marked it with the same exact colors, red being the part, green is the whole, blue is the percent. So Tamara again has a total of 250 cards, so that's the whole. Of those, 30% are baseball cards, that's our percent. How many baseball cards? So that's our part. So this time we are using an equation that looks like this. It's taking the percent as a decimal, multiplying it by the whole, and that gives me the part. So I'm following the same thing as I did before. I'm going to substitute in what I know. So the percent as a decimal, 30% as a decimal is moving the decimal over 2 places to the left. So I would get 0.3 or 0.30. Then it's times the whole. We said 250 was the whole, and that equals the part. That's what I'm trying to find. So now I have to do this multiplication. So I substituted the given values, and now I'm going to solve. So when I multiply, I get 75 equals x. And again, I need to state the answer in context of the problem, which means Tamara has 75 baseball cards in her collection, which is what they asked, how many baseball cards. So when we look at this second problem, this one is asking us to determine a percent. So it rained 9 out of the past 25 days. So remember, 9 would be the part, 25 would be the whole. What is the percent? We're trying to find the percent. So again, I'm using percent as a decimal times the whole equals the part. So I'm going to substitute for the given values into the equation. I don't know the percent, so that's going to be my x. Whole is 25, and the part is 9. So typically we don't see this written where we have the letter first. So I'm just going to make this algebraically look better. So better to write that would be 25x equals 9. Now I need to isolate for my variable. So I need to divide both sides by 25. And when I do that, I get x equals 0.36. Now this is a decimal. I have to be very careful that I'm answering the question. It says, what is the percent? So I need to change my decimal to a percent. So I move the decimal place over 2 to the right. Make a little note here, decimal 2 places to the right to make it a percent. So state my answer in context of the problem. It rained 36% of the past 25 days. Okay, last one. We're determining the total. So again, I marked my text and color-coded it. And I had 14 red apples. I don't know how many total apples there are, but I know that the red is 70% of the total. So again, percent as a decimal. So when I'm changing a percent to a decimal, I move the decimal point to the left 2 places. So 70 would have been here. I move it over 2, so I get 0.70, which is also 0.7. So I'm going to use that 0.7 times the whole. I don't know the whole is equal to the part. The part is 14. Okay, I'm going to just write this better because typically, again, we don't use parentheses in between a number and a letter. This is called the coefficient. So 0.7x equals 14. I now need to isolate for x. Divide each side by 0.7. When I do that, I get x equals 20. So again, state your answer in the context of the problem. There are 20 total apples in the basket. So if you look back at yesterday, what we did, I have the same 3 answers for all of these. However, one of the ways I used a percent proportion, which was part to whole equals percent over 100. And then today we did the percent equation, which is percent as a decimal times the whole equals the part.